This meeting is being recorded.
Hello, everyone. Today is August 10th, 2022. Today is Wednesday. This is the Kubernetes Data Protection Working Group meeting. We have a couple of agenda items today. The first thing is Ivan is to continue to give a talk with regarding to CPT. We had a um, very meaningful discussion a couple of weeks back. And even has some updates on this piece, and we're gonna go through this. And then Shin has some updates on the Volume Group cap. Last meeting we discussed this quite a bit. I think there's some leftover item over there as well. And then we will open the discussion to the group. I think Phone has some file change this the initial discussions over there. We'll see what how much we can get there in today's session. Cool. Even why don't we start on the first item first, the CPT one.
Yep, sounds good. Let me try to share my screen. Okay.
I need to make you a host. Hold on. I seen already did. So
Yeah. Okay, let me try again. So wait a second. Okay. Can you see my web browser?
yeah.
Yes.
Okay,
Good.
cool.
Thanks.
Yeah. Hi everybody. So yeah, about 4 weeks ago, we had some really good discussions and also learning along the way around like aggregated API server and how that can be very promising solution for the change block tracking cap and all the subsequent implementation. So I just want to do a very quick recap just so that to bring everyone on the same page. There are two main things that we got out of the meeting from 4 weeks ago. The first one is like using like aggregated API server. So we did an additional like prototyping to try to like hack like an aggregated API server and bend it to our will. So the first thing that we came up was like let me scroll down here. So this is the repo where we keep like the new like prototype. Like with an aggregated API server, we are able to like expose the APIs and like support the custom resource implementation with like a very Kubernetes native like user experience, whether it is using kubectl or client Go. So for example, right, like I can, because like all the requests to the change the block tracking change block tracking resources, like they are actually proxy through like the Kubernetes API server, and the Kubernetes API server delegate the handling of the requests to our custom aggregated API server. So from a user perspective, whether using kubectl or client Go, we're able to do something like that. You say kubectl create this resource, and then we can use kubectl get to get back the resource. Now without any like of course additional like CBT records like appended, but like we can take that a step further, and we proxy ourselves through the clusters, and we use like a HTTP client, where it may be curl or client Go or whatever. We hit the same endpoint and append like some query parameters to it, and now we can retrieve the same like object that we created earlier, but with all these additional change block deltas records appended. So of course, like in this like prototype, like all these are just mock data that is used for like the simulation. But if you in a real like end-to-end flow, like this data will have come back from like the storage provider CBT endpoint, and we're able to append that to the status sub resource of our original custom resource without persisting anything into SCD, simply by appending like all these additional query parameters to our requests. So the trick there was that like we were able to extend our aggregated API server to implement this REST connector interface. Now, for those of us who are familiar with Go, you could see like it allowed us to implement and define this method. And the trick here is that like we can return a custom HTTP handler, because the moment we have access to we can return a custom handler, we have, it opened up all sort of opportunities for us to work with requests and responses at a lower HTTP level. And by default, like some of the other interfaces, they are more restricted, like creator, getter, like they don't let you get down to that level. But with the implementation of this connector, we can get down to the level that we need to. So that was the first thing. So it really like let us like implement and provide a user experience like that is very like Kubernetes native and that's very familiar to the user. The user may be a human users or like a backup software. So that's the first thing. The second thing that we discover and discuss like during the last meeting was that like we were not able to implement this aggregated API server as a sidecar. The main reason there being that like if we have multiple like CSI drivers and they each have a zip CBT sidecar, they will end up stepping on each other's toes, because during the bootstrap process, all this aggregated API server sidecar is going to come up and try to register itself with the Kubernetes API server. You can just imagine like many of these sidecar will say, hey, I'm responsible for volume snapshot delta. And another one came up and said, I'm also responsible for volume snapshot delta. There was no way for the Kubernetes API server to multicast like a single request to all the sidecar. And so like, at the end, like the Kubernetes API server will only see one sidecar, even in an environment where we may have like multiple CSI drivers. And out of that conversation, we decided that, hey, why not follow like a similar pattern to the existing volume snapshot deployment model, where we actually have a common like service in addition to a sidecar. And that led us to this like most recent design, and we chatted about it. And then I went back and did some drawing and update like the prototype, and it seems to be very promising at this point. I want to quickly walk us through it, and then like there will be definitely many opportunities like to interact and feedback and questions and stuff along the way. So this entire bootstrap model currently, like in this design, it looks like this. Now we have an aggregated API server running as a common external service, likely as a deployment workload. And then like we also introduce a CBT sidecar. The sidecar get embedded into like the storage provider's CSI driver. So during the bootstrap process, the aggregated server comes up. There's only one of these in the entire Kubernetes cluster. It comes up and it registers itself with the Kubernetes API server and says, hey, from now on, I'm responsible for this volume snapshot delta custom resource. All of them come to me. I have an, I have an endpoint for it. I have a handler for it. I know how to deal with it. And then the sidecar, when it comes up during the bootstrap, it will register itself with this like new like custom resource definition that we'll be introducing. And it's basically saying that like this custom resource is really just we call it driver discovery. It's really just a way for the aggregated API server to discover like the CSI driver. So excuse me. So if you can imagine like in a clusters with multiple CSI drivers, and each one of them has this CPT sidecar, and all of them comes up, they're going to register themselves by creating this driver discovery resource. They're going to say, hey, what my name is, and this is the information that you will need to discover me, to send HTTP request to me. And we can also do like MTLS authentication using like a CA trust to generate like lift certificate, and then like the aggregated API server would use the same resource to discover where each CSI driver is. So this slide is really like about the bootstrap and the discovery. We haven't talked about like anything like kubectl get or client go get yet. does it make sense so far? Like in terms of like how the resource registration and the bootstrapping works?
Hey, Ivan, I just have one question. Yang did provide some links, right? Is this approach the same as what he suggested? Or is
It
this
sounds
little
it
different?
sounds similar. Yeah, it sounds similar. I think the part that he was referring to is just the client config property. So this
Okay.
client config, yeah, it's like it's a similar, exactly the same concept as a emission webhook. Basically, it's just a way of saying, for the, I guess for the pod to say, I have a service in front of me. This is my pod and my endpoint, and this is like the cert that we use to do MTLS authentication. So based on that one, I guess like the response from Jan, I think we are talking about the same thing, because he mentioned like we copy and then we have it already in our design.
Okay.
Okay, so
Hi,
yeah.
this is Pooja from Dell. So the actual change block tracking is implemented by the CSI driver. Is that something that the driver will implement an API?
Yeah, so the actual change block tracking, the records, the entries, yes, it will be provided by the storage provider API.
Okay, so the way I understood it, the aggregator is the aggregated API server is like a controller that will process the custom resources and invoke an API probably on the sidecar. Is that accurate? Okay.
Yeah. So let's go to the next slide. I think that's a good transition to the next slide, because exactly, that's what we'll be talking about next. So now, like after that, like the aggregated server is ready and the sidecar is ready. Now our client, the backup server, is going to send like a HTTP GET request to our aggregated API server. So it can be done using curl or client go, kubectl, whatsoever. And this endpoint here, the highlighted endpoint here, is actually exposed by the Kubernetes API server. So what I'm not showing here is like, what I didn't show here is like this request. It actually goes to the Kubernetes API server first, and the Kubernetes API server delegate or forward, or whatever the right terminology is, the request to our aggregated API server. So this is saying, hey, get me like a volume snapshot delta custom resource in the default namespace with the name of the test delta. So which is what like it was created earlier here. And then like so the response would just be like, as similar to, actually no, identical to what I showed you in the prototype README earlier. It will just return like the exact same object. We created return it back to the client. So in this case, like it's identical to a kubectl get volume snapshot delta space test delta. So now there's no like change block tracking entries or records yet, because we haven't hit the CSI driver. So now with this, of course, this is just it's no longer, so I'll come back to this. So the next request is that like we hit the same point, we issue the get request and we hit the same endpoint, but now we append a number of query parameters, and then we send it to like our aggregated API server. And then with the aggregated API server, like I mentioned about the connector interface, so it's able to identify, hey, now I need to do more because there are more query parameters there. So it's able to go to its etcd and pull out that driver discovery resource that was created during the bootstrap process. Now it's like, because like with the volume snapshot delta like resource, we are able to get the volume snapshot object, and then we are able to get the volume snapshot and content resources as well. And then we're able to see the driver name and other information like, for example, the snapshot class name. So with the driver name, we are able to ask for the exact driver discovery resource. And now this is how we discover, okay, given this volume snapshot delta, it has a base and a target volume snapshots. And then now we know which CSI driver is responsible for it, because we can extract the name from here. And then from that, we pull up and retrieve the driver discovery resource, which tell us the endpoint to this specific CSI driver. So we send like a HTTP JSON request. Excuse me. So by then, like we would have pulled up like the volume. We would have retrieved the volume handle. The lower level volume handles of the volume snapshot. So we can send like all this like I guess parameters in a JSON object to our driver, our CSI, the storage provider driver. And then the sidecar from here, like it would do like the very familiar workflow of, okay, I got this HTTPS request coming in with a post body. I'm going to issue a gRPC request over Unix socket to the CSI gRPC API to the actual CSI plugin sidecar. So this is the storage provider manage CSI plugin, and then this sidecar here, it would know like how to call into the actual CBT endpoint provided by the storage provider. So for example, if this is a CSI AWS EBS driver, this CSI plugin would be part of that, AWS EBS driver already, and then it would know how to do like the AWS credential authentication and authorization, IAM handling. It will know how to call into the EBS direct endpoint based on, and then like return the result back to us, to our sidecar, and our sidecar send it back to our aggregated API server and back to the client. And the response would look something like this. So you will have all this, the original object, and then with all this additional data coming back from the storage provider API endpoint. And all of this entire blob here, like is never like persisted into SCD. We got the response, we extract it from the response body, and then we just append it into our status sub resource and then send it back to the backup software, the client in this case. Does that make sense so far?
It makes sense to me. One question would be though, on the status, are we going to get pagination there?
Yeah, so I think it would be so I think like, okay, so yes, yes, we will get that, like because like whether it is like kubectl or client Go, like as long as like it looks for like some sort of like I guess, I think I'm glad I have this here. It looks for like some sort of like continued like lister properties that is inside the request. If it does, then it will know how to do like auto pagination.
Well, if you look into the parameter of the get, the first get on the top, you're going to see it have an offset, right? So the first one will be offset 0. And if there is more chain block need to be respond, then we will provide parameters next offset so that you can recall, you can call again with the next offset for the next page.
Yeah, so in our prototype, it is in our prototype, it is like a I guess like a more like manual steps, like the backup software says, hey, I need to submit another offset, second request, maybe offset 100. But like I think like I'm pretty sure like client Go and kubectl, they have like, or whatever Kubernetes client, they have built in automated pagination. So it looks for like a very specific like property. I think they call it continue. Like the key is literally called continue. The value is whatever comes back from the server. So and then with that, like it will know how to, okay, now I need to do more. So I think like it really boils down to like what sort of how do we want to how much flexibility we want to give it to the client. Do we want like the client to say, okay, I'm at page 20, I don't want the rest anymore, I'm done? Or like do we want to follow that more, I guess, kubectl experience? Say, as long as there's something, kubectl will just keep doing the auto pagination until you control C to kill the process or whatever. So I think there are some flexibility there, like I guess thanks to like the power and the flexibility of the aggregated API server, if that makes sense, hopefully.
Quick
Yeah,
question. Sorry. Go ahead.
Yeah, I was wondering who defines the contract of all the parameter names and the expected value, and
yes,
where the backup software would understand that.
Yeah, so the there isn't like a formal contract like a protobuf spec, because like from between the cloud backup software and the aggregated API server, it's really just HTTP requests. But on inside our code, we actually have to formalize it. So the trick is very similar to what, for example, kubectl exec and kubectl log does. Like we have to formally define an option object. So the option object is the one that says, hey, this is all the supported parameters. So there is some like a formal contract there, but it's not as formal as a protobuf spec where the client has to use the code that we generate.
And then how about driver specific parameters? Where do we define those?
Yeah, so there is some discussion in previous meetings around like I guess like okay, so there are two parts to that question. So for one, there are two parts to that to the answer of that question. Like the first part is like first of all, we for alpha, like we want to keep it to the minimum, and if there are more like driver specific stuff that we want to add to our API, we can that conversation is still open, and we can revisit that for example in the beta phase. Now the second part of the answer is like the feedback that we got was we don't want like to introduce like parameters that are very it's a bit vague, and I'm more like or more not vague but more like it's context dependent. So we don't want to have some sort of free form like map. You say, oh, if this is like AWS driver, it means this, or if this is a Google Cloud driver, it means something else. We were told not to include those kind of free form context dependent parameter into our API. Now the answer, I think like we were told that like many of those driver dependent parameters can actually be found inside the volume snapshot class. So if there's nothing, if the volume snapshot class, it feels like that might be the better place to put all those parameters based on this feedback we got so far. If that's not the case, again, happy to learn more about it.
Yeah, that sounds perfect. That's actually what I prefer as well. But the three things that define over there, I kind of I just want to make sure I understand this. It's kind of universally applies to all the drivers, and they're common. Like limit one, offset, fetch CPT is a different thing, so it's fine. So limit and offset, it's basically all the drivers will need that. Is my understanding correct?
Yeah. So these are the three that we have included so far.
Cool, thanks. Sorry, Dave, it was you.
Oh, was I saying something?
Yeah, you were asking something. Sorry, I cut you off.
No, I think it was fine. I think it was fine. What Ivan's saying here. Yeah. I would, I think the key thing is we want to make sure that the kubectl / Go client / Java client, whatever, talks to this without having to make changes. And so whatever we wind up with, as long as that works, that's good, right?
Yes. Yep. Yeah. So go ahead.
I also have a comment on page number 2. I think we discussed it in our private meeting, and I want to bring it out to the community too. So whether that box, that pink box on the left, it is the CRD that we need. Do we still need to have it as a CRD and stored in etcd, or it can be simply an internal resource maintained by the CBT API aggregated APIs part?
Yeah. So that is like I guess like the challenge that we need to address. I'm hoping we can address and find a solution to in this meeting. So I guess the first part of the question is, so found like we will need to register and define CR or CRD. So like, for example, like this Go code here, and also this this one here, the volume snapshot delta, it must exist at the code level, and then we must like register that with the API server. Second part of your question, does it need to be persisted into etcd? So now that is an interesting part. So if we look back at, for example, this diagram, we are introducing like the volume snapshot delta custom resource, and then as well as the driver discovery resource. So the challenge here in our prototype is like we persist them into etcd. Now they are really small resources, and the challenge is like I haven't found a way to persist this into the Kubernetes etcd. So what
You mean other than going through the API server?
We can't, because the API server will send it back to us. Yeah, exactly. Initially, I was hoping to say, hey, API server, persist this in your etcd, but the API server, the Kubernetes API server said, wait a minute, you told me that you're going to be responsible for this custom resource. So we got into this loop, and then eventually my whole thing just crashed and died. Yeah, so like I looked through like all the other existing aggregated API server that I can find. Like it seems like either like they don't persist anything at all, or they persist it into their own etcd, or some like like really like interesting and unique storage system, like even MySQL. I found an example where they store things in the MySQL database. But so the challenge here is like, yeah, like in the prototype, I have to spin up an independent etcd to say, hey, persist volume snapshot delta only this part here that the user gave us. And sorry, this one might be better. Persist this pink box into the etcd that is that is owned by like our aggregated API server. So to Fang's question, like I mean, like I think we had this chat during our last CBT engineering meeting. To Fang's point, like do we actually need to persist this volume snapshot delta at all? Like, can it just be like the client just send us like a request like this, and then somehow like we fake it and we pretend it is created but it's not, kind of thing?
Well, that's why I was thinking of using like a resource selector, and things like your your target and your base snapshot ID could be fields in the change block delta, theoretically, right? And then the selector would say, I guess it'd be a label selector, it's a resource selector would say what your base snapshot ID and what your target snapshot ID would be that you're searching for. But those would come through basically as arguments in the URL.
Right. So even with a resource selector or a field selector for that matter, like somehow like there still need to be this like object. Now whether it is persisted or not, Because
No,
otherwise,
I was thinking there would just be the change block. It could just be the change block delta record.
so because otherwise there won't be like let me see, because like the endpoint is tied to a resource, right? Because it's like a very
Yes.
like
Well,
RESTful based approach.
well,
There has to be an
it's-
actual resource.
It's tied to the API version, isn't it?
API version. Okay,
Because-
so yes, the API version, and then like it will have because like so all of like as far as I know, Kubernetes API server endpoints, all of them like follow this format. Sorry, it might be hard to see. It follow this format. There is like a group of version, and then you have to tell it the namespace
Yes.
and the actual name of the object. So if this was
Yes.
never created, then it won't even get to our aggregated API server. It would just return us a 404 and says like this thing doesn't exist.
Right. So what one idea that I had was that we would have, say, a change block delta would
Mhm.
be what you're looking for. So it would go blah 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 namespaces default change block deltas, change block delta.
So
And
it's
then-
so like this, like change block delta.
Right.
Okay, and
And then
it-
from there you're doing a field selector. I think you're correct. A field selector with what you want, which change block delta records you want.
yes, I think that might be doable. Let me think about this. So yeah, without a name, yes, I think without a name. So okay, so if we do something like okay, so maybe offset equal 0 and limit equal 0 or something like that. Or maybe like sorry,
Yeah.
not hard.
And
And,
then
and the volume name, right? And the volume snapshot name.
yeah, so
So-
you'd have to put in the field selector would have to be for, the volume snapshot.
So we have to
you know,
base equal, okay, and then target equal. I think that might be doable. It will become like I think it might be doable. Yeah, I think like because now it will interpret it as a list instead of
Yes.
a get, which is fine. Yeah, I think that might be doable for at least for the there's a chance that we won't yes, I think actually I would say there's a very good chance that might work.
And I think the other hack you could do, like if you wanted to store it as a CRD, define a different API version for the CRD so that it doesn't get directed back to the aggregated API server. So you're just using that CRD for storage.
Yes, that's exactly. That was exactly. I think like that would be the other solution. And it
Yeah,
goes
it's- If we have implemented like a stateless server, like we only process transaction, then I don't think we need to save anything at all on that CBT aggregated API part.
so I think, but we will have to look into. So okay, so yes, we will need to persist the driver discovery. Now I guess
Definitely.
exactly to Dave's point, like we can inside this pod we can have like sidecars. Like so there's an aggregated API server. Maybe we can have another like controller that says CBT.
And yes, I agree with that.
Or-
The driver discovery part is another, I guess, another CRD that we can define to help with controlling the functionality of the CBT. But the chain action of the different source, the volume snapshot delta chain action itself is a stateless chain action. You just get the different source snapshot and give it back to me. Just one chain action. Nothing need to be saved on that CBT aggregated API.
Yeah. So the interesting thing there is like, would we ever want to look back at this resource? I mean, so sorry. Like I guess in the past. So if you recall, like we used to have a little bit more here. Like we have things like parameters, etc., right? But now all of those have been removed because we want to. We talk about letting the parameters be stored inside the volume snapshot class. So right now, like because that was why like we had this, one of the reasons why we had this custom resource in the past, because we want to be able to retrieve all this during the second hop of the request. But now with this gone, yeah, I think, yeah, Fang, to your point, this become really like a stateless, well, I guess, yeah, quote stateless thing, that there's really just no reason we need to persist this. Now the question is like, for alpha, like implementation, are we okay with just I need to try. I think I feel like Dave's proposal will work. We should be able to just do this or whatever without a name of the, or like if we feel like, okay, hey, maybe down the road we may want to add more things in the spec that we want to the aggregated API server need to pull out from, we can again just extend this to another sidecar that says CBT volume, so like it's like a snapshot delta controller or something. So now like this thing becomes like a pot with like 3 sidecars, I guess, essentially. So and then each controller would be responsible for the different CRD. So this would be a kind of CRD. This would become
I'm sorry,
CRD.
I think
That would be-
I missed this. Why are those sidecars now? I thought those are like the common controllers, right?
Yeah,
Independent
so
controllers.
so like we need to, so first of all, like we need to
probably we do not need to discuss all the internal implementation at this detail. I mean, with that detail at this point, right? We just need a general idea.
Yeah, so a little bit of those details are important because it has to be shared in the CAP, and then folks have to understand it before they can approve it. So I guess
And I meant is about whether it can be a sidecar or not, right? It's just basically that it's just one server that do the forwarding of the request to a specific driver, right?
So yeah. So okay, so Xing, like to your question, like because we need a way to persist like some of these new custom resources, for example, driver discovery, we need to be able to retrieve it during this phase of the workflow, right? And like at this point, we won't be able to persist it into the Kubernetes etcd, because like the API, the Kubernetes API server will not let us do it, and in many like Kubernetes offerings, the etcd endpoint is not even exposed to the user. So in my prototype, I spin up an aggregated API server. I have a separate etcd to persist like all this like new like custom resources. Does that make sense? So hence, like we need a way to.
Can I ask a question here? Yeah.
Sure.
So we have 2 CRDs here. The driver discovery, actually, so we have the driver discovery object is actually straightforward. It can't get stored in CRD as a CRD, right? Because it's very small. There's really not much to it.
Yeah.
The reason we're looking at aggregated API server for the volume snapshot delta object is because it can get potentially large. There's a lot of churn there. And because of that, we want to use aggregated API server, right? So we are not going to have the best of both worlds where, for spec, you want to use a CRD. For the status, you want to use the aggregated API server. We're going to use aggregated API server for the entire object, right? And as far as like the multiple sidecars, I mean, these 2 objects, whether we use we made the decision that at least, volume snapshot delta wouldn't be a CRD, right? So potentially we can have a CRD for driver discovery because it's okay. I mean, if you want to store in etcd, it's not really a big issue.
Yeah.
And that CRD by itself is not really useful, right? So the fact that, we have multiple sidecars for different objects doesn't really help us much, because at the end of the day, you need to have both objects in order to proxy the request to the right CSI driver, right? So basically, I mean, the decisions are these: whether we want to use a CRD for driver discovery or not. If that makes things simpler, because you don't need an internal etcd for the aggregate API server. So that's the first decision. The second decision was basically we don't want to have a CRD for volume snapshot delta, because of all the churn in etcd, and it can get too large and whatnot, right? So there is no CRD there. I mean, so we should just forget about any CRDs there. And then the aggregate API server would become just the proxy that would process the internal snapshot delta object with the driver discovery object, which can be a CRD. And that's it. You know, we just have a single. We don't need to have like multiple sidecars for different types of CRDs because there's only one CRD, and that's driver discovery.
I think that makes sense. Yeah. I have another question related to page number 2, by the way.
Hang on a sec. I just wanna one sec. Yes, I think like okay. I'm just still trying to process like what was being said earlier. So yeah, I think like okay.
So the driver discovery, I mean, that shouldn't be handled by the aggregated API server, and that could be either by making a CVT or sorry, CRD that has a different API version, so it doesn't go to the aggregated API server, or you could make a config map, right? But in any case, it doesn't need to be stored by the aggregated API server. In fact, you probably want it to not be, because, like for example, if the CSI drivers come up, they need to register themselves. The aggregated API server may not be running at that point, right? So they're not really registering, they're advertising.
Yes. Yeah.
And so you want them to be able to advertise without that stuff being installed. So I think saying that those are standard Kubernetes resources that get stored. The place where we're running into a persistence requirement is because of, I think we have 2 ways to interact with things. So volume snapshot delta is being handled as a resource the user writes. They then gets a status that's updated. And that implies persistence, because once you write something, you expect that it's going to stay there. And so, for example, like if the aggregated API server goes down and comes back up, you would expect that the volume snapshot delta is still sitting there and that you can come back later and read the status from it. So that's where the persistence comes in, is because of the style that we're using here. Does that make sense to everybody?
It doesn't make sense to me. Basically, what you're saying is that aggregate API servers will require CRDs for persistence. Or something.
Well, they don't. It's because of the style that we're using here. Because we're doing this, write a resource, check the status that was put back into the resource.
So that the question is that the right way to do things?
Right. So what I was suggesting,
why can't we just use the get API, like the client go get API, whatever, some API?
Well, that's why. That's why I was suggesting that if we instead, so that's a model where we write some state, and then we check the status. Right. So that's one way to do things. If instead we took it as like the change block deltas, where we're listing out the ones we're interested in. And we could do that a couple of different ways. So one way would be put all of the fields in there, control things like target, base, offset. We can search across those using a field selector. And then if you look at it a little abstractly, in theory, all of the records always exist. It's not. So the state is always there is one way to look at it, or you could look at it as being stateless because it's on
the thing that doesn't make sense to me is like, you mentioned field selectors. These are Kubernetes object, capabilities, and if you are not using CRs or entry objects for the,
but these are absolutely Kubernetes objects,
right?
These are absolutely Kubernetes objects because they're being served via the API server.
Dave, what about RBAC permissions? I mean,
that should be applied by the API server. So the diagram here, the one that's up, that still doesn't show the API server sitting in between the backup software and the aggregated API server, right? But my belief is that the API server is applying the RBAC.
My question was related to that. I mean, does the API server require an object there?
It does. So yeah, in order for it to do RBAC, like that object needs to be. So okay, so I think one important thing to again, just reiterate, is like all at this point, the status, all these like additional CBT or CBD like entries, they are never persisted.
No,
So
but
yeah,
but the style that's being used here is you write a resource and then you read from the resource later.
so the only part that is
I know
read,
I think
right.
you use the resource to query. I mean, essentially by creating this resource, you've got an anchor point on which you can query. That's what it is.
yes.
So
Right, but the assumption is that any point in time in the future, you can come back because you wrote this resource, it should still be there.
yes, and that is a side effect of doing it. Yes, agreed.
And that's kind of why you need the persistence against the restart of the aggregated API server. Because you wrote a resource that has specific data that you wrote into it, and you expect that resource to be there in the future. And it would be a named resource, right? So you give it a name. So you'd come back with, Dave's volume snapshot Delta 53.
Yeah.
And so it's a unique thing that you created, so it has to be persisted.
So
It's probably its life cycle could be tied to the existence of the snapshots over there, right? When those reference snapshots go away.
But that means it has to be persisted because the aggregated API server can't just keep it in memory.
So
no.
yeah, so sorry, if we want to like have those kind of like user experience, user flow, let's say it's my aggregated API server restarted. Okay, so the only time right now in the prototype, right, the only time where the status sub resource has any entries is like the query parameters are provided. So if I restart my aggregate API server and I send back a request without any query parameter, I will only see what is persisted,
That's correct. But you had to persist that part.
Resource.
You had to persist that part plus the name of the resource.
Right. Yeah. So this is okay. So yeah, we are persistent. Right now it goes back to the conversation around like, do we want to persist this volume snapshot delta object?
Yes.
Without all these entries here. So
well, you kind of have to, because that's the contract, that the style that's being used, the expectation from anybody using it is that they write that resource, they could come back next week, next year, and it's still there. And even, at least within 15 minutes, which, restarting the API server would mean that if it's only in memory, it goes away.
So
this doesn't make sense to me. Oh.
So yeah.
What part?
The part that, first of all, like this left green rectangle here, as far as like the spec portion of it, this is something that the backup software specifies. So the backup software has an idea of what it is asking for, right? Yes. And, I'm okay with whether backup software internally stores that somewhere or, if it gets stored, as part of Kubernetes, in Kubernetes etcd. As far as like this status section, given that this is specified by the backup software, so it's not really, we're not talking about API server getting restarted. This is really backup software getting restarted. So backup software can know where it can resume work.
It's not the resuming. It's a write, then a read. So right, all that I've been showing here is the read of the record, but in order to have the record filled in, it had to be written first. So you have to write a snapshot, the volume snapshot delta resource. That would go to the aggregated API server, right?
When you say write, all it does is that it basically says, I want the diff between these two snapshots, right? And you have a bunch of blocks as the answer, right?
Well, no, because from the Kubernetes point of view, there's a resource that was written. And that was a volume snapshot delta resource. And it was named something like Dave's volume snapshot delta 5. So from the API, from a user of the API, you write a resource, then you read the resource and you check the status. At some point, the status gets filled in.
I want to make sure, like, so what do you mean by like the backup software knows what it's asking for? So everything in the status come back from the storage provider backend. Was it sorry if I butchered your name.
No.
Adair?
Ardalan, yeah.
So what do you mean by the
let
backup
me
software?
look, as far as the parameters here, we have basically everything in the spec section, right? The base snapshot and target snapshot.
Yep.
Right. These are the parameters, and these are coming from the backup software, correct?
Yes.
Right. So backup software already has some notion of what it's asking for, or
It absolutely needs to, yes.
per Dave's, term, what is writing to, and then I agree, at some point the backup software should know the results are ready, right? And given that the results are large, you can't get the entire set of results in one chunk, in one operation, right? And that's where the offsets come into picture, right? So the backup software knows that as a cookie that it has read, for example, the first 100 results, the first 100 blocks, so it can resume from there, right? Right. So as far as like the status, really, all the backup software really cares is that up to what point it has really processed the result. And first, whether the results are ready, and up to what point it has processed the results.
So it's not the status that's the problem. So that we can fill in on the fly, and that's what that's the plan, and that's fine. That's not a problem. The thing that's not really shown here, scroll up a little bit, would you, Ivan? So the URL that's being shown here isn't, so for example, what we're doing here is we're fetching something called a volume snapshot delta. That's the type of the record, right? And then it's named test-delta. So that's its name in the API server. The information like base volume snapshot name, target volume snapshot name, that's not in the URL because it was written previously. Because the first thing you had to do was you had to write a volume snapshot delta record with the spec. And then later you come back and you get the status of it, or you get the record, right?
Dave, I think you're misinterpreting thing. What I heard.
No, I don't think I am.
Well, what I heard him say was there is this time period between creating this object and the ability for the backend to be able to serve records. And if you keep state in this object, or the green object here, it could tell us when the backend is now ready to serve and so accept this call. Otherwise, let's say we make this query call, what would it do? It will just block you, right?
Or it gives you back nothing. It gives you back status is pending.
Right. So, but what I heard him suggest, and it's not saying we should or should not do it. What I heard him suggest is when this object is created, at that point, the aggregate API reaches out to the CBT HTTP sidecar for that driver, and A, I guess, validates the arguments, and B, initiates, right, some operations which can give back a status at some point.
But the way you get the status, so the operations are going to be write volume snapshot delta named test delta with the spec in it. Then you're going to retrieve it to get the status. Right?
Okay. Yeah, right.
Right. So that's the operation that would have to happen. And my point about persistence is that the amount of time between the write and the retrieve is undefined. And the expectation is that once you wrote it, you're able to read it at some point in the future. And that implies persistence, because if you restart the aggregated API server between the write and the read, the spec would disappear if it's only kept in memory.
Agreed.
Okay.
So that's why the need for persistence is because of the style that's being used.
Yes.
Okay. So I want to confirm.
And I'm questioning the style.
But it's not for the status. It's just for the spec.
Yeah. So we do want to persist, for example, this this custom resource that are created by the user or by the backup software.
Yes.
Yes.
Ivan,
if we use this style. And so that's, I think there are two options here that we could look at, and there's probably other ones, but I can think of two off the top of my head. So when I did that write-up the other week, what I had returning in the status was a UUID. And in my proposal, the original one was this volume snapshot delta record was a CRD, wasn't handled by the API server. And so that way, or wasn't handled by the aggregated API server, sorry. So that way you would read and write it in the normal way with the API server, and it gets stored into etcd or whatever is backing the API server. And the UUID was used as a selector into the change block deltas. It wasn't really pretty, but that way the persistence is handled by the API server and etcd, and the change block deltas are served back by the aggregated API server.
Okay.
Okay,
So
sorry, dear, we are running
I
out
need
of
to-
time.
Yeah, I
Sorry.
need to cut the meeting. Yeah, sorry about that.
okay.
I
mean, one fundamental question I think is basically we can't have it both ways, where the spec section is served by API server.
Hey,
I
Ivan,
then-
yeah.
can you add the API server, like Kubernetes API server should be in this picture? I add a comment in the agenda doc just to take a look of there is a picture, there is a diagram in Kubernetes doc.
Okay. So yeah, why don't we do this? So why don't we just I'll start with a conversation thread in Slack in the data protection working group. Assume everyone is there, and then
That's
if we
perfect.
need to have a different I guess another meeting, let's schedule that.
That's
So-
perfect. Thank you, Ivan.
Cool.
This is very great.
Yeah, it's
Thank
looking
you.
good. Thanks.
Yeah.
Thanks,
that's good.
everybody.
Thank you.
Thank you.
Cheers.
Bye.
Thanks for all the discussions.
Bye.